All right, so this is section A7. So it's Appendix 7. And the title for that section is Rational Exponents. Rational Exponents. Okay, rational exponent. Here's what I mean by rational exponents. You're going to see something that looks like this, and you cannot use your calculator with this one. So it looks like this. It's going to say simplify, and let's say we have something like 81 to the 1/2 power. 81 to the 1/2 power. So my exponent is 1/2. 1/2 is a rational number. 2 is a rational number. So when we said 81 squared, 2 is a rational number. 1/2 is a rational number. So remember, a rational number, remember you talked about two kinds of real numbers, rational versus irrational? A rational number, though, is any number that can be written in the form a over b, where a and b are integers. A and b are integers. Now remember, your integers are these. Your positive whole numbers and 0, and the negative components. So those are integers. But remember, you're in a fraction, your denominator can never be what integer? You can never divide by what number? 0. So you also have to say that b cannot equal 0. So if I look at the exponent 1/2, is 1/2 a rational number based on that definition? Yes, because 1's an integer and 2 is an integer. So that's why they call this a rational exponent. Now, 81, remember, is called the base. 81's the base. Remember the terminology. And 1/2 is the exponent. Whenever you're dealing with rational exponents, you can write rational exponents as a radical. You can write rational exponents as a radical. So remember in section 15.1, we had this radical. You had that in section 15.1. So you had this radical. When I simplified this radical, what's the answer? That's x to the 6th, y to the 9th. What's the cube root of 27? 3. What's the cube root of x to the 6th? X squared. What's the cube root of y to the 9th? Y cubed. That's what we talked about last class period. So when I said that every rational exponent can be written as a radical, then that means I can write this using a radical. All right, but let's talk about the definition, though. All right, so definition. X to the 1 divided by n, x to the 1 divided by n. So notice my rational exponent, the numerator is 1, the denominator is n. X raised to the 1 divided by n can be written as this, as a radical. Now here's how my radical looks. The nth root, remember the n's called the index. So in the one we just did a while ago, what's the index? 3. So it's the nth root of x to the first power. So notice that my denominator is the what? Index. Your numerator is the exponent of the base when you write as a radical. Okay? So then using that idea with 81 to the 1/2 power, what is that? What radical is that? 81 to the 1/2 power. Square root of 81. That's what that is. So 81 to the 1/2 power is the square root because my denominator is the index. Now remember, with the index being 2, you don't list a 2. It's understood to be a 2. So hence the phrase square root. But it's the square root of 81 to the first power, right? But 81 to the first is just 81. So that's the square root of 81. But what's the square root of 81? 9. So the answer is 9. So 81 to the 1/2 power is 9. Now, remember, you can do this without a calculator because I am going to ask you to write as a radical. But if you want to check, on your calculator, you would say this. You would say, put in the base first. What's the base? 81. So you'd say 81, and I'm raising it to the 1/2 power. So you see, you're raising it. See that little, it looks like a root. You're gonna raise that, and you're gonna, since 1/2 is a fraction, you put that in parentheses. If you don't put in parentheses, what's gonna happen?
Error.
No, not gonna get an error. You're gonna get 40.5. But you know the answer, not 40.5. What's the answer? 9. So you got to put that 1/2 in parentheses. So basically what happened was this. See what you're saying here? If you use the order of operations, you're saying I'm raising 81 to the first power, which is what? 81. And then you're dividing that by what? 2. Hence 40.5. But that's not what that's saying. That's saying you're raising 81 to what power? 1/2. So you have to put the exponent in parentheses. So 81 raised in parentheses 1 divided by 2, close the parentheses, and press equal, and you get what? 9. Okay? All right. So that's just using this definition right here. You can write all rational exponents using that idea. All right? Okay. Let's look at this one. Suppose I had the 27 to the 1/3 power. Don't use your calculator because I am going to ask you to tell me what radical this is. What's the radical? You got to say the right phrase. Cube roots of 27 to the first, which is just 27. Let's cube root of 27. 3. All right. All right. Now we're going to extend that definition. So it looks like this. Now remember, this definition was where the numerator was what? 1. The numerator of the rational exponent. But when we wrote it, remember when we wrote it as x to the first power, right? But any base raised to the first power is that base. But we saw last class period that the exponent, I don't know if we did this last class period. I think it was the radical. Oh yeah, we did. So like we did. No, I think we did. But let's look at this. Suppose We didn't do this, but suppose we had this though. The cube root of 27 squared. We didn't, but you can do that. What's the cube root of 27? 3. And what's 3 squared? 9. Okay. All right. That's the idea we're going to use in a little while. All right. Now let's extend that definition though. So I want you to look at this. All right. What if I had 27 to the 2/3 power instead? Not 1/3, but what? 2/3. Let's see how to deal with that. I know how to deal with the rational with the rational exponent where the numerator is 1, but that's a 2, right? Mm-hmm. All right. So let's look at this definition. If I have x to the a divided by b, x to the a divided by b, the b is still the index. Your denominator is still the index. Okay? Now the way I'm going to write it is going to be very similar to this. So that'll be the b root. Remember how I wrote the nth root? My denominator was the what? The index. My denominator is the what? The index. And when I rewrote it right here, I said the nth root of the base raised to this numerator, right? Same thing. So it'll be the base. And what's the base here? X raised to the numerator. Was the numerator? A. Okay. Very similar. Instead of x to the first, you're going to say x to the a. Now, I want you to use your calculator with this part right here. I'm drawing this arrow. And I want us to use a calculator with this part. The cube root of 27 squared. The cube root of 27 squared. So on your calculator, now here's the cube root button. The cube root button, you see where it has right above that power function here where we have that roof? Right above that in blue is the x root. You're gonna press the 3 first though, because 3 is your index. So always put the index first. What's my index here? 3. So you're gonna say 3. Now, but remember, it's 3 is the what? The index. So you're gonna say second, and then the x root. Looks like this. So that doesn't say 3 times. That says that the x here is what? 3. That's what that implies. And I want to raise that to, I'm going to put that in parentheses, 27 squared. Like this, 27 raised to the second power. Don't forget to close it. Press equal, you still get what? 9. So here's the point I'm trying to make. I got 9 on both of those, right? I got 9 here where 2 is on the outside. And I got 9 here where 2 is where? On the inside. Okay? All right, we're going to use that idea in a little while. Listen carefully. Let's go back over here. So this, if I rewrite this using a radical, that's going to be what root? Cube root of 27 squared. No calculator. No calculator. So then you got to ask yourself, all right, if I can't use a calculator, well, 27 times 27 is not going to be easy to figure out. Then I got to take the cube root of that, right? But how else can I write that squared? Where else can I put it? On the outside. So in other words, instead of putting it under the radical, I can put it outside. And now, what's easy to figure out, this one or this one? The second one. What's the cube root of 27? And what's 3 squared? 9. All right. So let's look at this one. Simplify. Simplify. 64 to the 3, I'm sorry, 64 to the 4/3. Yeah, but that'll be fine. 64 to the 4/3 without a calculator. Well, to do that, you're going to write as a what? Radical. Right now, it's written as a rational exponent. Because 4/3 is what kind of number? No, it is, but I want you to say rational. 4/3 is rational. And it's an exponent, right? So it's written as a rational exponent. You can write these as what kind of problem? Radical expression. What's my root? Cube root. So it's a cube root of the base. What's the base? And I'm going to put the 4 on the outside rather than the inside. Just like this. Now it's easy to deal with. What's the cube root of 64? 4. And all I got to do now is figure out what 4 to the 4th power is. So 4 to the 4th means 4 times 4 times 4 times 4. A little bit of work I have to do, but it's doable. It's a lot easier to deal with than saying 64 to the 4th power. 4 times 4 is what? 16 times 4 is what? And as you can say, 64 times 4. So 4 times 4 is 16. 6 times 4 is 24. What's that, 256? So the answer is 256. Okay? That's all you do. That's all that is. Just knowing that one definition. All right, let's look at this one. Suppose we had... Suppose we had the, oops. (64) x to the 9th power, y to the 15th power, raised to the 1/3. What do you want to do?
Half would be 4x to the 3rd and y to the 5th.
What is it?
4 to the 3rd. Oh, I'm sorry. 4. I'm not there.
Well, just say what you say. I mean, it's 4x to the 3rd, y to the 5th. Right, but in your mind, though, you're basically saying the cube root of that, right? That's what you're saying. And that is now the last section. What's the cube root of 64? Cube root of x to the 9th. Cube root of y to the 15th. Right? So there's your answer. So 4x cubed, y to the 5th.
I think I'm going to get that right.
All right, suppose we had 81 x to the 12th power raised to the 1/4. What radical is that? Fourth root of 81 x to the 12th. Now what's the fourth root of 81? 3. What's the fourth root of x to the 12th? X to the 3rd. There's your answer. Okay? That's all that is. Now let's look at this one. Now listen carefully to this. All right. Okay, now, you got to be careful with the negatives. Now, what is being raised to 1/2 power? What do you think is being raised to 1/2 power? Is it negative 16 or 16? It's one of those. It's one of those two. 16. 16 is being raised to the 1/2 power, not negative 16. Because if I wanted negative 16 to be raised to 1/2 power, it would have to look like this. So notice the difference between those two. Okay? There's a difference. The first one, only 16 is raised to the 1/2 power. The other one, negative 16 is raised to 1/2 power. Okay? Let's check up at the first one, the left one. If I write this as a radical, was the only thing raised to 1/2 power? So I'm going to cover this negative up for right now. So this really becomes the square root of what? Well, what's out in front? So what's the answer? Negative 4. Okay? If I do this one, then that's the square root of what? And from what we talked about last class period, think about where we are right now. What's the square root of negative 16? 4 times 4 is not negative 16. It's not a real number. There's no number times itself that's ever going to be negative, right? So remember, that's where you put not a real number. Now soon, though, when we start talking about imaginary numbers, you're going to rewrite this as 4i. Because that's going to be important when we get into quadratic equations where we use a quadratic formula. All right, but for us right now, it's just not a real number. Okay? All right. Let's look at, make sure I'm doing all the ones I need. Okay, let's look at this one. Simplify. Negative 625 raised to the 3/4 power. What is that as a radical? What is that? Negative 625 raised to the 3/4 power. How do you write this as a radical? As a radical, what is this as a radical? Negative 4th root of 625 to the 3rd power. Now you'll put the radical in parentheses because the negative's out in front, right? To the 3rd. That's how it's going to look. Okay. So only remember, if you need to cover this part up and then rewrite it. Okay. See, rewrite it. You're going to say 625 4th root. Put that in parentheses, and that's being raised to what power? 3rd. Now put the negative out in front. Okay. What is the 4th root of 625? Do you think? 5. Good. But it's going to be 5 to what power? 3rd. And whatever that is going to be what? Negative. So what's the answer? Negative 125. That's the answer. Okay? Now let's use the calculator. Let's check it. So your calculator, though, now remember on the worksheet it's going to say rise a radical. That's what I expect you to put as a radical, okay? And then the answer, you put negative 125 in the answer. Let's check using a calculator. So you're going to say negative 625 raised. Now, how do I write that 3/4? In parentheses, 3 divided by 4. Close, press equal, and you get negative 125. Okay? I'm sorry.
Thank you.
All right.
Thank you.
Okay.
But on this section, you're not gonna want us to use a calculator at all.
No, don't use a calculator. You can use a calculator to check. What's the problem?
Oh, no, just the square root.
All right. Okay.
He
It'll
didn't say
be-
it was easy this time.
No, I didn't say. All right. Okay, so let's suppose we had this. Simplify negative 64. No, that's the wrong one. Sorry. $80. Oops, I messed up. 32. All right, let's change it. Negative 32. I'm going to change that because your worksheet has negative 32. Nope. Your worksheet has negative 32. So let me change it.
You would probably never notice that.
Oh, yeah, you would have. You would have. All right, negative 243. The one on the worksheet is easier than here. It's not because the worksheet's easier than that. Raised to the 4/5. Now remember the negative's on the inside, right? Okay, not on the outside because there's parentheses there. All right, let's change that to radical. So my radical is going to be the 5th root of negative 243, all raised to the 4th. All right. What do you think is the 5th root of negative 243? Negative 3. Because 3 times 3 is, I mean, guys, it's not going to be that bad because you're going to try 2 times 2 5 times, right? Hit 5th root. So what number times itself 5 times is 243? Do you think 2 is going to work? No. You think 3 is going to work? Well, let's try it. What's 3 times 3? What's 9 times 3? What's 27 times 3? And that's where you get stuck, right? Write it out. Do this. 27 times 3 is 21. So 81, right? What's 81 times 3? 243. So there you go. So the 5th root of 243 then is negative 3. But that negative 3 has to be raised to the 4th power. All right? A positive 81, though, because a negative 3 times a negative 3 is a positive 9. A positive 9 times a negative 3 is a negative 27. A negative 27 times a negative 3 is a positive 81. It's 81. So there's your answer. So this is the radical right here. So in the blank, this is when it says if it asks you to write it as a radical, that's the radical, and then this is your answer. Okay. All right. Let's look at this one. Simplify. Okay, simplify. 8 27ths to the 2/3. 8 27ths to the 2/3 without using a calculator.
Yeah.
And in fact, if you use a calculator, it'll give you a decimal sheet, but you know from last semester how to change a decimal to a fraction anyway.
Never mind, not even.
Don't even go there.
Never mind.
All right.
Confused.
Rise a radical. What's the radical? Cube root of 8 over 27, all raised to the 2nd power.
That wasn't so bad.
That's the radical. That's not the answer. That's your radical. Now let's find the answer. What's the cube root of 8? 2. So this is your radical. What's the cube root of 27? All that's raised to what power? Now, what's the answer? 4 over 9. There's your answer. Now, let's check the calculator. So, in your calculator, you're going to put 8/27 in parentheses. So, parentheses 8 divided by 27. Make sure you do that with me. Okay? Then you're going to raise that to the 2/3. But 2/3 has to also be what? In parentheses. Close. Press equal. Gives you this decimal. But you remember how to change a decimal to a fraction. You're going to say what? Second PRB. And then press what? Enter. You get what? 4 9s. Okay? You get 4 9s. Okay. Now, let's look at this. Suppose we had 64 x to the 8th power, 8 raised to the 5/2. All right, now I gotta review with you something before we do that. Okay? All right, let's review something first. All right. What is, based from last semester, what is x cubed times x to the 2nd power? What do you think that is? X to the 5th. Remember the product rule. The product rule. When you multiply like bases, xx, what do you do to those exponents? You add them up. So it'll be x to the 5th. Okay? You add the exponents. Okay? What if you had this? Where you had x cubed raised to the 4th. So it'll be x to the 12th. So that's called the power rule. The power rule. So the power rule. So when you have a power raised to power, you multiply. And it kind of makes sense because that outside force says I'm multiplying x cubed times itself how many times? 4. And based on the product rule, 3 plus 3 plus 3 plus 3 is what? 12. Okay? So those are the two rules that you're going to need to remember. Product rule and power rule. All right, now let's look at the one we wrote down. Okay, let's change that to a radical. That's going to be what? The square root of 64 x to the 8th, all raised to the 5th power. What's the square root of 64? So this is your radical. So we're going to go in the process of simplifying. What's the square root of 64? 8. What's the square root of x to the 8th? All that's raised to what power? 5th. So that's where I'm at. All right, now now you have to use your calculator. There's no way I would expect you to say 8 times 8 64, 64 times 8 is whatever it is, and 8 whatever 5 times, right? All right, so let's use your calculator on 8 to the 5th power. So 8 to the 5th, use your calculator. 8 raised to the 5th power. Oh, good Lord. Yeah, so 32,768. But x to what power, though, now?
20.
X to the 20th. Because we're using a power rule. Power is the power you multiply. Okay? That's all that is. All right, and what about this one? x to the 1/6 times x to the 2/3. X to the 1/6 times x to the 2/3. You want to multiply that out. What rule are you going to use? Product rule. You multiply like bases, right? When you multiply like bases, we do the exponents. Add them up. So we just got to figure out what 1/6 plus 2/3 is. Use your calculator for that one. But I'm going to show you how to. I'm going to remind you how to find this. But let's use a calculator for right now. You're going to say 1/6 plus 2/3, right?
Mm-hmm.
Press equal. You get this decimal. You got to change that to a fraction. So what do you press? Second. P or B. Press equal. And you get what? 5/6. So this becomes x to the what? 5/6. You're done.
That's it.
That's it. Now let's remind ourselves how if we lost our calculator, what we need to do. What's the LCD? 6. 6 times what is 6? 1 times 1 is 1. 3 times what is 6? 2 times 2 is? And 1 plus 4 is? 5. Okay? Let's look at this one. Suppose you had 7 raised to the 2/3 times 7 raised to the 3/4. Can I use a product rule? Yes or no? Yes, because the bases are the same. They're both 7s. So all I need to do to the exponents is do what to them? Add them up. So in your calculator, what's 2/3 plus 3/4? 2 divided by 3 plus 3 divided by 4. You get this decimal, 1.4166666. Second, P or B, press equal. You get 1 5/12. Now once you rewrite it back as a rational exponent though. So y'all agree that 2/3 plus 3/4 according to the calculator gives me 1 5/12, correct?
Mm-hmm.
Let's change that back to an improper fraction. 12 times 1 plus 5. All right. So the answer is 7 to the what? That's it. That's all you do. The directions will say, leave the answer as a positive exponent. Don't do anything else. Don't change it to radical. Don't change any of that to radical. Don't change this answer to radical. Don't say that's the 6th root of x to the 5th. Because it's going to say, leave the answer as a positive exponent. To have an exponent, is it positive? Yeah. To have an exponent, is it positive? Okay? So your question is, what if it's negative? You're not going to have a negative. You dealt with negatives last semester, but there's nothing in my math lab that talks about the negative, so I'm not going to talk about it. Okay? Any questions on this? All right? So when you get the worksheet, there's only one worksheet. And now I'm going to open my math lab, but don't work on it right now because you need to study for that test Tuesday. So just start working on it after Tuesday. I'll give you about a week and a half to do it. It's very simple. So here's the worksheet. So the first part, without using a calculator, you can do this. But nowhere in there does it say change to radical. So I don't need to see it. All I need to see is the answer. So just put the answer here, okay? If you want to change to the radical, just do it in the back. Put the radical part in the back. Because all I want here is just the answer. Just the answer. Now here I am telling you to do what? Rise the radical first and then tell me what the answer is simplified. We just did these two. See those? Don't remember what I said. Don't change that to radical. Leave it as x to the what? 5/6. Leave this as 7 to the 15/12. That's what these are. Okay? All right, so that's all of A7. So we're done with A7. That's all that was. So any questions on that? All right, now let's look at this.